Now this circuit is composed of resistances with equal magnitude, let's say small r. All of these resistances are of equal magnitude, small r. We need to find the equivalent resistance between point A and point B. Now again, if you carefully observe, the entire circuit is symmetric about the line AB. If we see this line AB, entire circuit is symmetric about it, which means we can fold the circuit on the upper half to coincide with respective points on the lower half. Now once we do that, we need to keep in mind which all points will coincide. For example, this point will remain the same as it's on the line of symmetry. This point coincides with this point. This point remains the same. This point coincides with this point. This remains the same, and this remains the same. Which means if I were to draw the equivalent resistance or equivalent circuit now, considering one half only now, because we have folded the circuit about this line AB. So what we are left with now is, this is point A. Now this becomes R by 2, because once this and this coincide, this resistance and this resistance are in parallel. So this is R by 2, this remains R, this becomes R by 2 as well, as these two are in parallel. These two are also in parallel now, so this also becomes R by 2. This remains R as it lies on line AB itself. This becomes R by 2 again, and this also becomes R by 2. Right? Now if you see, this R and R by 2 are in series, this R by 2 and R are in series. So my equivalent resistance circuit becomes, this is R by 2, this becomes 3R by 2, this is R by 2, this becomes 3R by 2, and this becomes R by 2. This is point B, this is point A. Now if you see clearly, this is reduced to nothing but a Wheatstone bridge, because the ratio of R by 2 and R by 2 and 3R by 2 and 3 by 2 both are same and equal to 1, which means no current will pass through this resistance. We can do away with this resistance. Now the remaining circuit boils down to this R by 2 and R by 2 in series, because this R by 2 resistance can be removed because there is no current flowing. This is the property of the Wheatstone bridge, right? So we are left with R by 2 and R by 2 in series become R. This is point A, and now 3R by 2 and 3 by 2 R by 2 also in series become 3R, which is in parallel to this R, and this is B. R and 3R equivalent is 3 by 4R. 3 by 4R is our equivalent resistance, and that is our required answer.